Open Arlo is a project about taking the closed system of a manufactured toy and opening it up to explore its functionality and programmability. The first step to the project is to get access to the chip. Here, we're essentially doing it wrong by boring a hole through the side of the plastic casing when you can see we're actually working between two regular screw mounts. There's no way we should use that saw.
Cutters, like a pair of heavy-duty scissors.
If we'd spent a little more time exploring, we would have noticed the Phillips screw heads and wouldn't be misusing a pair of wire cutters to cut through the plastic casing. Shortly after this, we took the screws out of the sides of the casing and were able to open it up for easy access.
Ooh, circuit boards.
Well, one of the things that I'm looking at is that things that are polarized typically have different color wires. So that means that orange and brown are probably the motor wires. If I were a designer, a button is the same. It's basically just out and back, so it's the same color wires. So I think the blues are a switch. So I'm going to cut the blues first, and I'm going to try to leave as much of this. This is the point of no return with this toy. Once we do this, we're not coming back.
Arlo will never work the same.
I'm going to reach in there and get as much of this wire as I can because I want to use it. There we go. Okay, now the next thing I'm going to do is pull this out and strip a little bit of this back. A pair of wire strippers is mandatory for this. Okay. Okay, now I'm going to take a jumper wire, and we got blue and blue, so I'm just going to peel a blue off of here or something. We want to make this breadboard friendly, so I'm going to cut this in half. I'm going to strip this back. So now I'm going to twist these wires together.
It's just kind of divided between a couple of teaching styles that
And I'm going to twist this together.
By connecting the jumper wires to the existing wires, you've basically made it possible to plug that switch into a breadboard.
Or an Arduino.
I'll
Plug this into pin 4. 0, 1, 2, 3, 4. Pin 4 and ground. And now I'm going to test this by plugging it into Arduino and writing a piece of simple code. So here's Arduino. I'm setting pin 4 as an input pull-up. So it's an input with a pull-up resistor on it that's actually pulling that pin high. It's providing 5 volts to that circuit. So that circuit will be normally high because it's pulled up. So it's a way on the chip to provide power to a pin. So basically what we've said is internally on pin 4, provide it with power. Okay, so it's high right now. So the other thing I'm going to do is I'm going to say serial dot begin, and I'm going to give this 9600. So serial is a library. It's a chunk of code that lives in Arduino that we don't see. We pulled out a specific item in that library, the begin function, and we tell that begin function to operate at 9600 bits per second. Okay? So now what I'm going to do is I'm going to say serial dot print, and this has got to be capped, color, like a nice done cookie, Doc, print, LN prints on one line, and I'm going to say print the digital read on pin 4. So what I'm doing is I'm setting pin 4 up as a powered switch. I'm calling that serial function, and I'm saying in the loop over and over again, print what you see on now. Where's my button? So it's high right now, normally high.
Should be up in there.
If we push it, something should happen. There's 0,
Yep.
0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1.
So when you push it, it
So I'm going to solder these wires to make sure we have a good solid electrical connection, and we can move on from this without the worries of, oh, that wire's not connected, or
I just saw someone mentioned Python, but I thought it was this actually
it's the whole pie. It's the computer.
So what are you doing?
So we've got the button, which is an input, but now we're going to start on the outputs. These two white wires both go directly to the speaker, and I can see that clearly. So I'm going to clip those.
Next step.
We're going to strip those wires. Those sure are skinny wires. I think I might have taken a little bit of that one with me. No. There we go.
So the wires have been soldered, and we threw some electrical tape on there to insulate them so that they're not shorting out against stuff. I'm just going to clean them up a little bit. Now, on the Arduino, the pins that are denoted with the tilde are pulse width pins, pulse width modulation. It's a fancy way of saying we turn that pin off and on really fast. What we're going to use these pulse width pins for is to play a tone through the speaker. So I'm going to plug one side of the speaker into the source of that tone. That'll be pin 9. I'm going to plug the second side into ground, someplace where it has to go home, and I'm going to add some code.
So we've got the Arduino board connected to the dinosaur. This is the speaker that's currently going to pin 9, and this is our switch, which is currently going to pin 4. And these have associated grounds plugged in over there. Once I got it working well enough, the question then became, what else can we get it to do? One of my 3rd grade students figured out how to add a button and a second tone. And that was just the beginning of the fun. Open Arlo check-in, day 2. Arlo's on the bench. We've got him connected to a Raspberry Pi for convenience more than anything. This code is the new code. It has 2 loops in it because, or rather 2 if-then statements, because we added a button. So now the original button makes that noise, but this button makes that noise. There's the code. There's the dinosaur. Red, green,